Welcome to this bite-sized, memorable look at the world around us. I'm Jim from Nature's Work. Successful reproduction is the aim of all living organisms. Here we're going to take a look at a range of strategies adopted by alpine plants, covering both sexual and non-sexual methods. Sexual reproduction produces genetic variation in the offspring, which allows the species to adapt to new environmental conditions. And the mixing of this genetic material provides an evolutionary advantage through natural selection. In the Alps, there's a wide variety of pollinators that exist, but as you climb higher in altitude, their numbers and diversity decline as the environment becomes harsher and the winds become stronger. Large showy flowers are really common in the Alps and beauty to see, and they help to attract pollinators despite the added energy costs in producing them. They've also got the downside of shading the leaves below, which would reduce photosynthesis. But the benefits for having these flowers seem to outweigh the costs of energy in producing them, maybe perhaps highlighting the importance of genetic mixing. Alpine flowers have a few other adaptations. They have a large excess of energy-rich ovules and also lots of pollen, which both go towards increasing the chance of pollination. Some flowers do self-pollinate, but that doesn't help the genetic mixing, but the seed possibly would then travel far away from its parent and have a better chance of cross-pollinating with another plant. Heliotropism, or sun tracking, you can experience a lot of alpine flowers showing this mechanism, and it's designed to concentrate the sun's energy, optimizing the conditions for seed growth and development. Wind-pollinated plants, again, very common in the mountains. The clouds of pollen are cast into the air with a chance of landing on a suitable flower. It's a very unspecific strategy, and it's unlike the insect carrying pollen directly to a flower. But the advantage of the simplicity and the effectiveness of it, where pollinators are less common, is quite overwhelming. Now we look at the asexual or the alternative strategies, the non-sexual reproductive strategies. Essentially, these are all clones and cloning. Another term would be fragmentation, but it's where a little bit of that plant vegetatively propagates and becomes a new plant, a genetic clone of the parent. And the example we've got in this photo here is mountain sorrel. Interestingly, at low altitudes, mountain sorrel will reproduce sexually with the flowers, but as you go higher in altitude, they're more likely to reproduce asexually. Tussock grasses. These are grasses which produce new individuals, and they're called ramets, which in Latin, I believe, means a branch, and they grow as a single plant or a clump rather than spreading over a meadow, and the new individuals remain connected to the parent plant. Whereas stoloniferous grasses or plants which reproduce with stolons, these are horizontal underground stems spreading out from the parent, sometimes called runners, and they eventually generate roots but remain connected. And it's very difficult to age these plants, as the original parent may die, but the younger offspring remain living. And some of these clones are known to be well over 1,000 years old, even as old as when Jesus was around, so up to 2,000 years. But no individual is that old, but the clone has survived for that long, which is a great strategy for an alpine plant. Tuft-forming herbs, so these are non-grasses. These grow just like the tussock grasses do, and they're connected to the parent plant in a clump. An example here is Mount Cenis bellflower. And then there are the mat-forming herbs, and these have overground shooting or rooting shoots. And a good example here is with Fleischer's willow herb, sometimes known as alpine willow herb. So that produces overground shoots. And then there are the ones with modified stems which live underground, and these are known as rhizomes. Ginger is a classic example of a rhizome. And these rhizomes produce shoots, and they're very common in snowbed species. This gives them a great selective advantage when the snows melt and they can rapidly grow. The example here is coltsfoot. Mobile scree plants also have rhizomes, or many of them do, and they're very elastic and allow them to move over that mobile environment. A really interesting phenomenon is something called vivipary, which is where the plant makes a baby plantlet or a bulbil from an ovule, but without pollination. This is the example, the photo here of alpine bistorp, and you've got the white flowers above, and below you have the bulbils, the red bulbils. And at low altitudes, they will reproduce sexually with the flowers. They will produce plants or the seeds, but at high elevations, a bit like the mountain sorrel, they almost exclusively reproduce with the bulbils, those red structures below the flower. This is the other example. So you've got of vivipary. So instead of having a bulbil, you've got a baby plant with little roots that will form, and then they fall to the ground and just carry on surviving that way. So a direct clone of the parent, not a genetic variant, but for longevity of that plant, very successful strategy. And then finally, we'll look at this method called apomixis. And this is where a seed develops, but without pollination. So it's unfertilized, which is a phenomenal thing. You've got the flowers that have been produced there in the ladies' mantles. And it's basically, it's disguising sexual reproduction, and it produces that genetic or genetically identical offspring. Ladies' mantles do this exclusively, whereas brambles or dandelions do it that way, but they also reproduce sexually. If you'd like to know more, why not join me on a course in the Swiss Alps? Alternatively, you could purchase my book, The Alps, A Natural Companion. Just go to my website, natureswork.co.uk, where there's also a range of nature-based playing cards available.